So in this video, we'll look at a couple of more differentiation rules for other trigonometric functions. So the given two rules are the most famous ones. Sin x becomes cosine x and cosine x becomes minus sin x if you take derivatives. And actually there are more trigonometric functions you have learned. For example, you may be wondering what is the derivative of tangent x, right? And actually the hint is that we can actually view tangent x as sin x over cosine x. And if you view it this way, we can apply the quotient rule. I mean, if you take the derivative of tangent x, it's the same as the derivative of sin x over cosine x. And there's a quotient rule that you can use. So it's cosine square x in the bottom. The top is going to be cosine x times derivative of sin x, which is cosine x, minus sin x, and the last term is the derivative of cosine x, which is minus sin x. So if you look at it this way, by the quotient rule, we can simplify further. The top is cosine square x plus sine square x. The bottom is cosine square x. And cosine square x plus sine square x is 1. So which means the derivative is 1 over cosine square x. But please recall some trigonometric identities. There's a trigonometric function secant x, which is defined as 1 over cosine x, right? So it means what? It means the derivative of tangent x can be written as f prime of x equals secant square x, right? Because this function now is really the same as secant square x. Because secant x is the same as 1 over cosine x. So it looks like a new formula. It helps you do a lot of calculations whenever it involves the function tangent x and the derivative is just the same as secant square x. But theoretically speaking, it is not something entirely new because it can be derived by using the quotient rule, like what I've done here, right? But anyway, that's the formula you can memorize. So similarly, we have a similar formula for the function f of x equals cotangent x. Actually, the derivative is going to be minus cosecant square x. And moreover, we have some other rules. For example, when you have f of x equals secant x, the derivative is going to be tangent x, secant x. So it doesn't look very natural why it becomes tangent x times secant x, but the fact is that you can derive this formula on your own by viewing secant x as 1 over cosine x. Then you can differentiate it by using the quotient rule for 1 over cosine x. And you would notice that the answer you get for f prime is exactly the same as tangent x times secant x. And similarly, we have a last formula with you. F of x equals cosecant x. And the fact is that the derivative is going to be minus cosecant x times cotangent x. And these are the formulas that you can use to help you find the derivative for more complicated functions that involve tangent x and secant x, cosecant x. We can do some exercises here. So please look at the current function, which is tangent of cosine of x. This one is a composite function. So please don't make the mistake that f of x is the same as tangent x times cosine x. They are not the same because the red one is a product. You see, it's a product of two functions. But currently, we are looking at the composite function. You take cosine for the x first, and you take tangent, composite functions. So it's a typical case where we can use the chain rule. And the f prime of x is going to be a multiplication of two factors, where the second factor is going to be the derivative of cosine x, which is minus sin x. And for the first factor, it's going to be the derivative with respect to variable v for the function tangent v. And as our formula shows before, it's going to be secant square v, right? So the answer of f prime would be secant square, and v is the same as cosine x. And this factor is multiplied to minus sin x. And it's the answer to the derivative of this problem. And so we'll look at one more problem. Now f of x is the same as product of two functions. So we can actually use the product rule. And product rule means we can use this formula u prime v plus uv prime, right? And let me write down the easier part first, because I can just copy it from above for the two functions like this. And what is u prime? U prime is the derivative for the function secant of 2x. And as I told you before, secant function, we have a formula, so it becomes secant tangent like this. But as a chain rule problem, we have to apply a chain rule for what you have in the bracket. The bracket contains the function 2x. So if you take derivative, it's going to be 2, right? So it means u prime is actually the same as 2 times secant of 2x times tangent of 2x. And similarly for v prime, we can do something similar. Cosecant of 3x derivative is the same as cosecant minus cosecant of 3x times cotangent of 3x. And this one needs to be multiplied to the derivative of 3x, which is 3. So v prime is the same as minus 3 cosecant of 3x times cotangent of 3x. And that's the answer to this problem.